first lesson on confidence intervals. By the end of this unit, we're hoping you'll be able to identify an appropriate point estimator and calculate the value of a point estimate, interpret a confidence interval in context, determine the point estimate and margin of error from a confidence interval, use a confidence interval to make a decision about the value of a parameter, interpret a confidence level in context, describe how the sample size and confidence level affect the margin of error, and explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. Oftentimes in statistics, we want to answer questions like, how long does a battery last on the newest iPhone on average? Or what proportion of college undergraduates attended all of their classes last week? Or how much does the weight of a quarter-pound hamburger at a fast food restaurant vary after cooking? To do that, we can choose a random sample to represent the population and collect data. But we can't be certain that our conclusions are correct because of the natural variability between samples. Probability helps us account for the chance variation due to random selection or random assignment. This unit begins our formal study of statistical inference, which is using information from a sample to draw conclusions about a population parameter such as p or mu. We will start with a focus on confidence intervals for estimating the value of a parameter. Our work will be based on the sampling distributions that we studied in the last unit. The first thing we need to talk about is a point estimator. A point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called a point estimate. For example, a quality control inspector wants to estimate the mean lifetime, mu, of the AA batteries produced each hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. The mean lifetime in hours of the batteries of one such sample is x bar equals 16.718 hours. That sample mean, x bar equals 16.718 hours, is the point estimate for the population mean mu. So you try. Identify the point estimator you would use to estimate the parameter, and then calculate the value. What proportion P of US adults would classify themselves as vegan or vegetarian? A Pew Research Center report surveyed 1,473 randomly selected US adults. Of these, 124 said they were vegan or vegetarian. So what is the point estimator you would use to estimate the parameter? You're going to use your sample proportion, p hat, as the point estimator. And in this case, that's just 124 over 1,473, or 0.084. All right, try this one. You have a counselor at a large high school wanting to estimate the mean amount of sleep, mu, that students got the previous night. She selects a random sample of 10 students and asks them to record the number of hours they slept last night. Here are the results. So remember, you're going to use the sample mean, x bar, and you get that by adding up all the values and dividing by 10, so it's 6.6 hours. A confidence interval gives an interval of plausible values for a parameter based on sample data. We use an interval of plausible values rather than a single point estimate to account for sampling variability and increase our confidence that we have a correct value for the parameter. So take a look at this cartoon. As this cartoon suggests, there is a trade-off between the amount of confidence we have that our estimate is correct and how much information that interval provides. So in the cartoon, sure, the high temperature is going to be somewhere between 40 below zero and 200 above. We can be very confident of that, but that doesn't give us very much information. Confidence intervals are constructed so that we know how much confidence we should have in the interval. The most common level is 95%, and you will learn how to interpret confidence levels shortly. The confidence level C gives the overall success rate of the method used to calculate the confidence interval. That is, the interval computed from the sample data will capture the true parameter value in C% of all possible samples when the conditions for inference are met. For example, the Associated Press and the NORC, Center for Public Affairs Research, recently asked a random sample of US adults how much financial difficulty they would experience if they had to pay an unexpected bill of $1,000 right away. Overall, 65% of respondents admitted they would have a little or a lot of difficulty. A summary of the study reported that the 95% confidence interval for the proportion of US adults who would admit to experiencing some financial difficulty is 0.613 to 0.687. That is, they are 95% confident that the interval from 0.613 to 0.687 captures the true proportion of all US adults who would admit to experiencing some financial difficulty paying an unexpected bill of $1,000 right away. You will likely be asked to interpret a confidence interval. Here's what you should say. We are blank percent confident, usually 95%, that the interval from blank to blank, whatever you calculated, captures the, and then your parameter in context. When you're interpreting a confidence interval, make sure that you're describing the parameter, not the statistic. It's wrong to say that we are 95% confident that the interval from 0.613 to 0.687 captures the proportion of US adults who admitted they would experience financial difficulty. The proportion who admitted they would experience financial difficulty is the sample proportion, which we know is 0.65. The interval gives plausible values for the proportion who would admit to experiencing some financial difficulty if asked. The margin of error gives us the interval of plausible values for a parameter based on data from the sample. We're going to need two components: the point estimate, which is used as the midpoint of the interval, and then the margin of error to account for sampling variability. The structure of the confidence interval is point estimate plus or minus the margin of error. And we can visualize a C% confidence interval like this. The point estimate, you can see right there, is at the midpoint. And the margin of error is added and subtracted from that midpoint to create the interval. The margin of error of an estimate describes how far, at most, we expect the estimate to vary from the true population value. That is, in a C% confidence interval, the distance between the point estimate and the true parameter value will be less than the margin of error in C% of all samples. So here's an example. A counselor at a large high school wants to estimate the mean amount of sleep that students got the previous night. We've seen the numbers that she got from the 10 students, and she asked them to record the number of sleep they got, and based on this sample, the 95% confidence interval for the population mean amount of sleep for all students was calculated to be between 5.39 and 7.81 hours. So first we're going to interpret that interval. What we will say is that we are 95% confident that the mean number of hours slept by the population of all students at this large high school is between 5.39 and 7.81 hours. The point estimate should be the midpoint of that interval. So just add the two numbers and divide by 2, 6.6 hours. The margin of error is what we added and subtracted from 6.6 hours to get the interval. So you can just subtract to tell that it was 1.21 hours. Now, it's recommended that high school students get 8 hours or more of sleep each night. Based on this survey, the students claim, on average, students at this high school are not getting the recommended amount of sleep. We're going to use the confidence interval to evaluate that claim. Now remember, the confidence interval only goes from 5.39 to 7.81. All of the plausible values for mu are less than 8 hours in this confidence interval, right? The top one is 7.81. So this interval gives convincing evidence that the students at this high school do not get the recommended amount of sleep on average. Now, you are going to do an activity to help you understand what it means to be 95% confident. I have put a worksheet in Schoology in today's folder, and you can open that up and follow the instructions, or you can follow the instructions in the Pear Deck, which I also put in the Schoology folder, and I gave you student access so that you can maneuver back and forth within that if you want to see the instructions. And that's it. I would like you to submit your responses to the worksheet or the questions that are in here on Schoology before we meet class next, and we will continue from there. So enjoy the rest of your asynchronous day, and I will see you soon.